Hi, I'm Paul, and this is my first YouTube video on magnets. I've been doing a lot of research on magnets and free energy and zero-point energy, and so I've got some ring magnets. They're ceramic magnets, and I got them out of a pair of old speakers a friend of mine gave me, and I've been looking at technology like the serial energy, or SEG, as well as some other types of stuff, and I wanted to start with something cheap and inexpensive without spending a lot of money on you know, extra magnets and this and that and the other. So anyway, yeah, speaker magnets, great source of magnetism if you want to experiment. Anyway, what I've done is I've taken this magnet as well as 4 others, and I've put them all together in a stack, and got a really useful tool. It's a pole identifier. So you just press the button, hold it by the magnet, and it tells you which poles. Green is for south and red is for north. So on this particular one, I've taken a little diagram out of Illustrator that I made for segmenting and measuring position on the magnets, and I just pasted it right on the top of the magnet. And so we're going to identify this magnet because I'm going to be experimenting and showing you this one. So on top we have the North Pole, and at the bottom we have the South. Here we go. You see there, North and South. So we have North here, South there. So what I've done is I've got some neodymium magnets, and I've labeled these poles accordingly, South and North. And what I want to do is, I know that it's north on the top, and so I have a really strong magnetic attraction here with the South Pole to the north side, and I'm just going to let it snap on there. And it just wants to go to its own place. And I noticed when I was playing with these earlier that it would find its own position as I rolled it around the magnet. Oops. And what I wanted to do was determine where this position would be every time I rolled it around. Let's see if it was consistent. So let's move it around over here. That seems like a stable spot. Now I'm going to mark the spot right here with a little mark right there. And then I'm going to roll it, roll it to the next position and see where this ends up, and it looks like it's lined up right about here. So I'm going to put on number 1 or 2 marks here on the inside. And the next position looks like it's lined up on this line. We'll also do 1, 2, 3 little marks. 4. Got 1, 2, 3, 4. 5. So let's do this. We'll make 5 a dot with a circle. And 6, nope. It's going to go right back to its starting position there. Okay, so as I bump this thing around here, it kind of finds a new position. This one may have something to do with the diameter of the magnet. that's lining up to a new spot as it rolls around, because it seems to be changing. Oh, it's got a new position. Look at that. Interesting. Okay, so let's see if I put this back on starting position. It may have something to do with the circumference of the magnet versus the circumference of the ring magnet. So I'll move it to here, move it to here, move it to here, move it here, and back to the first spot. Yeah, very interesting. It could have something. Oh, there we go. Look at this. As I twist the magnet around. Ah, interesting phenomenon here. Now I'm rotating this this smaller magnet on its axis, and it seems to be finding new positions. Very interesting. Alright. Maybe I should be marking the starting point on that magnet so we know which position. So let's roll to there. Alright, so let's do this. We know that's south, so I'm going to put a line right like that. Oops, can you see that? A little line there. A line through it. Anyway. So as I roll this around, I got one, that's one complete turn. It looks like two complete turns. It's nearly 3 turns. 4 turns. Not quite lined up again. 5 turns, well, just over 5. You can see the mark. It's a little bit off. Yeah, that's a little better. So you can see the red mark on there. We're going to roll it around to the start position. So it's lined up there. Lined up there. A little bit off there as we roll around here. And do again, looks like we're moving about 10 degrees. These rays here are in 10-degree increments when I built this pattern in Illustrator. So probably based on the circumference of the small neodymium and the circumference of the large one, we're moving 10 degrees, but it still seems to be lining up. It's so certainly must have something to do with the pole or the magnetic field, you know, around the end here, and its position when it comes into the field of the larger ring magnet. So yeah, there's some real interesting things going on with the magnetic lines of force between these two magnets. So the next thing I want to do is I have another another small neodymium magnet, and holes are marked. And I was playing with this earlier, and I noticed that the way that these two, when they get around the surface, repel each other on the outside in reference to the magnetic field of the ring magnet. So right now I have a really strong attraction. And if I try to remember that we have the top here being north, and so when I place this north field in relation to that, it just pushes it away. But it's also attracted to that, that neodymium. Alright, so I'm going to take this one, the second one, and I'm going to place it on there. I don't want to let it snap on there because I can chip that ceramic magnet. And put this here in the field of view. Now watch this as I roll this one around. Here, I'll get my fingers out of the way. It wants to push that next one. Look at that. Right on around, out of the way, as this one lines up. Moves that one. There's the stable position. And it just got a little closer there, and it didn't like that. Pretty interesting. And kind of got this idea from watching the videos on the SEG, the serial electronic or electromagnetic generator. And I was noticing the way the magnets were circling around the ring magnet, and so I'm trying to understand a little bit of that technology and the theory behind that without going into the math and the digging deep into physics. Okay, well, I'll show you some more video on this as I experiment. I'm going to get some more magnets. Matter of fact, they're on order. And I'm going to be doing more experiments with ring magnets. Well, very powerful. It really wants to move. And anyway, fun with ring magnets.